All right, here we go. Polar and nonpolar bonds. All right, not in the notes right now, but super important is that we talk about for a second the concept of electronegativity. So we learned about this in our periodic table unit, but basically electronegativity is a numeric measurement, and you can find a list of them on table S. So you're going to need to use table S a lot today, but you can find a list of electronegativity values on table S, and what these values represent is an atom of an element's ability to attract electrons when forming bonds. So electronegativity is a big concept here because we're going to talk about how bonds formed in terms of whether the bonding pair of electrons in a covalent bond is shared equally or unequally between the bonded atoms. All right, so basically it depends on how well those atoms can attract that bonding pair of electrons. In other words, those atoms' electronegativity values. All right, so electronegativity is how well an atom attracts a pair of electrons when it forms a bond with another atom. Some atoms are better electron attractors than others, and that's going to be a major concept. Okay, so there's two types of covalent bonds that you can have. You can have a polar covalent bond, a polar bond between two nonmetals, or a nonpolar covalent bond, a nonpolar bond between two nonmetals. If you have a polar bond, you get one because the two atoms that are going to bond together, those two nonmetals, there's a difference in their electronegativity values. And we can like shortcut that by saying delta En. That's what delta En means. It means difference in electronegativity values. Okay, so if you have two atoms that are going to bond together, particularly atoms of different elements, usually there is some difference in their ability to attract a bonding pair of electrons. There is usually some difference in their electronegativity values, meaning one atom is a better electron attractor than the other. So what this means is in a polar bond, the sharing of the bonding pair of electrons between the two atoms, it's unequal. One atom is going to pull harder on that bonding pair of electrons than the other. So what that means is that bonding pair of electrons is going to physically be moved closer to one atom in that bond. And that is going to be the atom with the higher electronegativity value, the one that's got a better electron attracting potential. Okay, so why is it a polar bond? Well, polar bonds have charged poles, like positive and negative ends to them, positive and negative poles. Where do those poles come from? It comes from that unequal sharing of bonding electrons. The atom that is a better electron attractor, the one that kind of gains the electrons from the other atom, like that red atom is pulling on the electrons harder, it has bigger electronegativity value, it's kind of gaining them. It's not really gaining them though, so we won't say it's like a full-on negative charge, that atom. We'll say it's a partial charge. So in a polar bond between two nonmetals, you don't get full positive and negative ends of the bonds. You get partial charges because the electrons in the bond are not being truly lost or gained. They're just being shared unequally. And the atom that's a better electron attractor, the one that kind of gains the electrons, is the partial negative end of that bond. And the atom that kind of loses the electrons, the one that has a lower electronegativity value, the lesser electron attractor, that atom is going to kind of lose the electrons in that bond to the other atom because it kind of loses them. That nonmetal becomes the partial negative of that polar covalent bond. Okay, so polar bonds are bonds between atoms of two different nonmetal elements. One atom is usually going to be a better electron attractor to the other. It has a higher electronegativity value. That atom is going to kind of gain the bonding electrons and become the partial negative end of that polar bond with charged poles. The other atom is going to have a lower electronegativity value. It's going to kind of lose the bonding pair of electrons. And because it's kind of losing the electrons, it's going to get a partial positive charge. Okay, so there's your bonding, your polar bonds, where the poles come from due to unequal sharing of bonding electrons. Okay, so probably a lot of this is going to go quick because I kind of talked about it all in this one slide, but that's okay. So in a polar bond, your bonding electrons are going to be shared unequally. Okay, so that unequal sharing is important. Maybe star it. That unequal sharing is where the partial negative and partial positive charges come from in your polar bonds. One atom is kind of going to lose, another atom is going to kind of gain. Okay. That unequal sharing creates partial charges on either side of the bond, partial poles, partial positive and partial negative poles. The atom with the lower electronegativity value, that says lower En, is going to be the partial positive end of the bond, the one that's going to kind of lose the bonding pair of electrons. And the partial negative end of that polar bond between two nonmetals is going to be the nonmetal with the higher electronegativity value, the one that's going to kind of gain them. It's going to get a partial negative because it's kind of gaining some bonding electrons. Okay. Talked about that. Okay, so a rule of thumb if your bond is polar. Now, there are numeric values associated with polar, and then we're going to talk about nonpolar and what actually makes a bond ionic. The electron is no longer shared, transferred. The gizmo is going to go through those, but you don't really have to know those for the Regents exam. So here's what I can boil it down to. Bare minimum for polar bonds, know that they generally occur between atoms of different elements. There's going to be some difference in electronegativity always in a polar bond. Why is there a difference in electronegativity? It allows for the electrons to be shared unequally in that bond, and it creates charge poles. This right here, super important, like quadruple star it. You're going to say it again and again as an explanation in the gizmo. You're going to be often asked to explain why some bond is more polar than some other bond. When a bond is more polar than some other bond, what that means is the strength of the partial negative and the partial positive poles on those bonds, like it's still partial, right? If you say one bond is more polar than some other bond, it means the strength of those partial charges is stronger in the bond that's more polar. And the reason why one bond would have stronger partial charges than some other bond is because there's a bigger difference in electronegativity in those bonding atoms. So basically, the bigger the difference in electronegativity, the more polar the bond becomes. That's what this bullet's all talking about. The bigger the difference in the ability of the atoms to attract those bonding electrons, the more polar the bond. Okay, let's try this. Let's practice. We're almost done. Bear with me. Come on, keep paying attention. You got this. We want to know which bond is most polar. Okay, what's most polar? It's going to be the bond with the biggest difference in the atom's ability to share electrons. So in other words, it's going to be the bond with the largest or the greatest electronegativity difference. And then if it is polar, we got to figure out which end of the bond is the partial positive and which is the partial negative. Okay, so most polar means biggest difference in electronegativity. Remember, you have values for that on table S. I don't even need to look up the electronegativity of bromine. It is 3.0 if you want to write it down. But like if you have two atoms of the same element bonded together, there's no difference in electronegativity. The difference here is 0. This is actually what a non-polar bond, our purposes, is going to be. That bond isn't even polar, doesn't even have charge poles. We'll talk about it in a minute, but when there's no difference in the ability to attract the bonding pair of electrons, they're shared equally and you don't get charge poles. Hold on, something is telling me I have to look at my Meet tab. Oh, it almost canceled me out of the call. I almost had to do this again. Truth is, I actually already did this once, so I don't really want to do it again. All right, I'm getting distracted. All right, so back on that bond is nonpolar. We're going to talk about why in a minute. All right, so I don't know if you have to change C. If you do, please change it. Now we're down to bonds between atoms of different elements. So if we look up in B, carbon versus oxygen, carbon's electronegativity is 2.6. Oxygen's is 3.4. So we do have a difference in electronegativity here, which means the bond is going to be polar. That difference is 0.8. That is an 8. And here in carbon-hydrogen, carbon's still 2.6. Hydrogen is 2.2. Okay, so we do have another difference in electronegativity, but this time it's only 0.4. So both B and C are polar bonds. They're both polar because there's some difference in electronegativity. But to answer this question, which one's the most polar? B is the most polar. How do I know? It has the bigger difference in electronegativity. There's more unequal sharing of the bonding pair of electrons in B than there is C. So the partial positive and partial negative ends of that bond are going to be stronger in B than they are in C. Okay, so speaking of partial charges, both B and C are polar. So which end of the bond is positive and which end of the bond is negative in those two polar bonds? I'm gonna have to clear my annotations because this pen I can't make it any smaller. But to go back to it, B and C are polar. So which end is positive, which end is negative? Carbon's electronegativity in B is 2.6. Oxygen is 3.4. Oxygen's the better electron attractor. It has the higher value for electronegativity. It's going to be the atom that kind of gains the electrons. Or in other words, the oxygen is the partial negative end of that polar bond. The carbon with 2.6, it's kind of going to lose that bonding pair of electrons to oxygen. Since it's going to kind of lose them, and it has the lower electronegativity value, it gets the plus or the partial positive end of that polar bond. In the carbon-hydrogen bond in C, carbon is 2.6 and hydrogen's only 2.2. In that bond, the carbon's the better electron attractor. It's going to kind of gain the electrons and be the partial negative end. And the hydrogen, the lesser electron attractor, is going to kind of lose the electrons and be the partial positive end of that polar bond. Okay, so for when you get to your gizmo, the higher value is the negative one, the one that kind of gains the electrons, the better electron attractor. All right, let's wrap this up. If you've got nonpolar covalent bonds, what makes a bond nonpolar, not have poles? Well, for us, it's usually going to be because you have atoms of the same element bonded together. They're going to have an electronegativity difference of 0. It ultimately means they're going to share the bonding pair of electrons equally. No one's going to pull on them harder. No one's going to kind of lose or gain them. So you're not going to get any charged poles. Nonpolar covalent bonds between nonmetals don't have poles. The big thing to know about them is those electrons are shared equally because the electronegativity difference is 0. That says delta En, oh my gosh, equals 0. There are, you'll see in the gizmo, there are specific numeric criteria, but for us, just think of a nonpolar bond between atoms of the same element. There's no difference in electronegativity, which means they share the electrons equally. All right, so we basically have to figure out here if the bonds are polar or nonpolar. We're almost done. This is the last slide. And if they're polar, you know, which end is positive and which end is negative? What are those charge poles? Just get rid of 4. That's technically an ionic bond. The gizmo will show you why. Let's talk 1, 2, and 3. There are 2 nonpolar bonds here, ones that won't even have charged poles. They're 1 and 3. Why? Because in 1 and 3, the difference in electronegativity between 2 hydrogens is 0. The difference in electronegativity between 2 chlorines in 3 is 0. Since there's no difference in electronegativity, they're going to share their electrons equally between their atoms. There's no partial positive and negative poles generated. Nonpolar bonds, nonpolar, don't have poles. 4, I said, like, I just get rid of it for now. In 2, carbon's electronegativity is 2.6. We just did this one. Hydrogen's is 2.2. So these are nonpolar. Sorry, I messed up. Those are nonpolar. No poles. Electrons are shared equally. In 2, though, we are going to have a polar bond because we do have an electronegativity difference here. There is going to be an unequal sharing of those bonding electrons. So that is a polar bond. The carbon, the better electron attractor, the one that's going to kind of gain the electrons, is the partial negative. The hydrogen, the lesser electron attractor, the one that's going to lose the bonding pair of electrons, kind of, is the partial positive end of that polar bond with poles. Okay, that is the overall idea. Again, it's expected you at least start the gizmo after the lab quiz. There'll be a bit of time, there should be a bit of time next class for you to work on it. but it is the expectation you begin it after your lab quiz. All right, you got about 10 minutes to look stuff over for your lab quiz. Good luck. I should see you Wednesday or Thursday, depending on when your next scheduled class is. Bye, guys. See you soon.